So before we start talking about properties and solving equations and all the other things that we do in algebra, we need to be clear about what exactly it is we're talking about. And what we mean by a rational expression is a special kind of fraction. It's a fraction where the numerator and denominator are both polynomials. For example, x squared plus 1 over 7x. That's a rational expression. These polynomials can get as complicated as we want them to be, as long as there's one on the top and one on the bottom. They can also be simple, right? For example, this is a rational expression. That expression on the top, the 1, that is a polynomial. It's obviously an extremely basic one, but it does qualify. And of course, we can flip this over. This expression, x over 1, is also a rational expression. Now, of course, this simplifies to x, which isn't very interesting. I mean, we've kind of gone backwards, back down to being just a regular polynomial. So, well, yeah, every polynomial does technically meet the definition of a rational expression. We're going to be specifically interested in the ones that actually have a variable in their denominator. All right, so you notice here this special little qualifier at the end here, right? Q, that's the polynomial in the bottom, can't be equal to 0, right? And that comes from our basic algebra arithmetic concept that you can't divide by 0. So this brings us to our next topic here. Where is a rational expression undefined? Well, this is actually simple enough. It's undefined at any value of x where the denominator is equal to 0. So let's look at my example here. Right, let's just kind of calculate a few values. If we calculate f of 0, that's 1 over 0 minus 1, which is negative 1. And we can calculate, f of negative 1. That's 1 over minus 1 minus 1, which is minus 1/2. But look at what happens when I try to stick 1 in there. F of 1 is equal to 1 over 1 minus 1, which is 1 over 0. And of course, you can't do that, right? You can't divide anything by 0. So the way we qualify this here when we're talking about rational expressions is I would say that this particular rational expression is undefined when x equals 1, because that's the value that makes the denominator equal to 0. And you kind of see this sets up our method here for how we answer this question, where is a rational expression undefined? It's undefined wherever the denominator equals 0. So let's look at this example here. All right, it's the same question. For what values of x is the expression undefined? And I know that it is undefined wherever the denominator equals 0. So let's do that. Let's take the expression in the denominator and set it equal to 0. So to answer my question, all I have to do is solve this equation, right? And we've got some nice numbers here. This expression factors to this, and that gives us two answers. The first factor gives us x equals 3, and the second one gives us x equals 5. So those are the values where this particular rational expression is undefined. And you can check this real quick, right? If you put 5 into the expression, you get 5 minus 3 in the numerator, that's 2. And in the denominator, you get 5 squared minus 8 times 5 plus 15. And you can confirm, right, quickly just do the arithmetic there, that yes, this does come out to 2 over 0. Right, so that's a value where this rational expression is undefined or doesn't exist. All right, so take a look at this guy, right? Try doing this one on your own. Pause the presentation, see what you come up with, then start it up again, and you can see how I answer this. All right, so what we're going to do here is we're going to take the denominator 3x squared minus 2x minus 1, set that equal to 0. And solve this. Let's see, I think this thing is going to factor. This is 3x plus 1 times x minus 1. And we take the factors, set those equal to 0, and we get two values where this is undefined. It's undefined at x equals 1, and it's defined over here at x equals negative 1/3. All right, so simple enough, right? So a simple enough process to answer these questions. Take the denominator, set it equal to 0, solve that equation, and you're going to get your answers. So where are we going from here? Right now that we've seen what rational expressions are and kind of done a very basic operation with them. The next several lectures are going to follow kind of the same process you follow when you're learning about fractions, because fundamentally that's what these rational expressions are. They're just a special kind of fraction. So in the next lecture, we're going to talk about simplifying, and then in the next several lectures after that, we're going to go through basic arithmetic processes: multiplication, division, addition, and subtraction.